Hello, this is Greg Coldwell, just providing my submission for the first extra credit opportunity. And before I begin, let me just say that I really do appreciate this opportunity because with my test scores, I could certainly use all the help I can get. So thank you very much. The basic premise was to provide a solution to a problem that wasn't specifically addressed during class or in any of the exercises, but which was available from the text that we've been provided so far. I'm fascinated with pi. It's a cool number. I think a lot of people like it. So I wanted to do something with pi. I thought, can we count how many times each number is represented in n number of decimal places of pi? And the good thing is that we can. So the basic premise, and this is a very rough sketch, is all we have to do is find out how many decimal places we want after pi, isolate those decimal places to make it a whole number, and then check the last digit to see what number it is, add to the tally for whatever that last digit is, remove that last digit, and then go back to step 3 and just kind of repeat the process until we have no more digits left. And these various things, those are the page numbers where these topics are actually covered for how we can actually do this programmatically. Pardon me on that. Anyway, so this is the algorithm in action. We've got our variables for the numbers that we're going to keep tally of, and we just obtain number of decimal places after pi. We're going to do 4 in this example. So there we have pi to 4 decimal places. So we have to isolate those 4 decimal places and make it a whole number. Here's the math to do that. Essentially, we're just going to make pi a whole number, and then from that, we just subtract 30,000, and what we have left are the 4 decimal places, but now as a whole number. Next, we can identify the last digit of that number, basically with the formula, and it identifies that digit as 5. So we increase the tally of 5 by 1. And then from that, we remove that last digit and go back to step 3. And this is the process that we're going to do until we have no more decimal places left. All right, so here we are in Python, and I've written this program that does what we just described in the previous slide. So it prompts for a number of decimal places after pi, it isolates them, and then it identifies how many times numbers 0 through 9 appear in those decimal places. So we'll just kick it off, and we'll use an example of 15 for this example. It tells us, okay, well, these are the 15 decimal places after pi. Basically, what it did is just remove the 3 dot from it. And now we can check it and get the results of, okay, well, there are 0 zeros, blah, 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 all the way down the line. Now, the reason why I chose 15 is because the math.py module is only accurate up to 15 decimal places of pi. After that, it does some rounding things, and the numbers just get way off. But what I did, because I wanted to check the accuracy of this thing, is I created a variable down here called pi1000, and I imported the first 1,000 decimal places after pi. And so it's just a really long number, but there it is. And so what we're going to do is just trick this program to use that instead, so we can check the accuracy. So we're going to run it again. It doesn't matter what number we input because the program is just going to use this variable to check. Anyway, but we'll get the results that should be accurate. So we run it again, and we'll just choose 1 because it doesn't matter. And there are the results. So it's telling us that the results for the first 1,000 decimal places of pi are these. And just to double check that, what I did is I imported the first 1,000 decimal places of pi. Each line is 50. And then I just created these count sums that, add 1 every time there's a 0 in the entire range of the first 1,000 digits. Do the same for 1 through 9. And what we can see is that the first 1,000 digits, our program accurately matched it. And that's a good thing. Makes me very happy. Once again, thank you for the opportunity, and I'll see you guys online.